In this video, we'll do an example of trigonometric substitution with an integral containing x squared minus a squared. For this one, we're to evaluate the integral of the square root of x squared plus 4x minus 5 over x plus 2 dx. Now, before we do any trigonometric substitution, we first got to use the method of completing the square on the quadratic underneath the square root. So again, this integral, the integral of that square root of x squared plus 4x minus 5 over x plus 2 dx, that's equal to the integral of the square root. Now, like I said, we're going to use the method of completing the square. So we're going to take the number in front of the x, the 4, divide that by 2, square that, add it, and subtract it inside the radical. So we'd have x squared plus 4x plus 4 minus 4 minus 5 all over x plus 2 dx. So we did the plus 4 minus 4 underneath the radical, so that's the same thing as just adding 0, so we didn't actually change anything. But this is now equal to the integral of the square root of the x squared plus 4x plus 4. That's a perfect square, so that becomes x plus 2, that quantity squared, and then minus 4 minus 5, so that'd be minus 9 all over x plus 2 dx. Now what we're going to do is we're going to do a substitution and let u equal to the x plus 2, then du would be dx. So this gives us, when we do our substitution, we'd have the integral of the square root of u squared minus 9 all over u du. And now we're going to do a trigonometric substitution where our a in this case, because 9 is 3 squared, so a is equal to 3. So what we're going to do is we're going to let u equal to 3 secant of theta. Then du would equal to 3 secant of theta tangent of theta d theta. So doing our substitution, we'd have that this is equal to the integral of the square root. Now instead of u squared minus 9, this will be the 3 secant of theta squared, so that would be 9 secant squared of theta minus 9 all over 3 secant of theta times the 3 secant of theta tangent of theta d theta. Now simplifying this out, this is equal to the integral. We could pull out the 9 outside the radical, but remember when you do that, you take the square root of that 9, so this would be 3 times the square root of secant squared of theta minus 1 all over, let's see, those, that'd be 3 secant of theta times the 3 secant of theta tangent of theta d theta. You could have also canceled that 3 secant of thetas on the top and bottom. Let's see, so that secant squared of theta minus 1, remember that's equal to tangent squared of theta. So we'd have, this is equal to the integral of, like we were saying, that 3 secant of thetas, those could cancel. So this would be 3 times the square root of the tangent squared of theta, so that'll just be tangent of theta times another tangent of theta, so this would be 3 tangent squared of theta d theta. Now we're going to use the identity that the tangent squared of theta is equal to secant squared of theta minus 1. So this gives us that our integral would be the same thing as, let's see, 3 times the integral of secant squared of theta minus 1 d theta. So that would be 3 times, taking the integral of that, the secant integral of secant squared of theta, that would be tangent of theta minus theta plus c. So you could distribute that 3, so that would be 3 tangent of theta minus 3 theta plus c. Now we got to do our back substitution for the trigonometric substitution. So we do know that from our original trigonometric substitution that u was equal to 3 secant of theta, so that gives us that secant of theta was equal to u over 3. So drawing our right triangle, we're letting that angle be theta. So this tells us that the hypotenuse over the adjacent was u over 3. So the length of the hypotenuse was u, the length of the adjacent was 3. So we'd say that the length of the side opposite of theta would be the square root of u squared minus 9. So this gives us that tangent of theta is equal to what? Opposite over adjacent, so that would be the square root of u squared minus 9 all over 3. So substituting that in, so we'd have 3 tangent of theta that becomes 3 times that square root of u squared minus 9 over 3. Minus 3 theta. Well, if secant of theta is equal to u over 3, then theta is equal to secant inverse of u over 3. Or you could also say that theta is equal to cosine inverse of u over 3. Either one would be the same. So we'd have 3 times the secant inverse of u over 3, and then plus c. But remember, this is not our final answer, because remember our original integral had x's, not u's, so we got to then plug in the x plus 2 in for u. So this would give us, let's see, the 3's cancel from the first term, so we'd have the square root of, instead of u squared minus 9, that would be x plus 2, that quantity squared, minus 9, minus 3 times secant inverse of, now would be x plus 2 over 3 plus c. And if you want it, you could rewrite this as a square root, like squaring that x plus 2, that quantity squared, and then the minus 9, so that gives you the square root of x squared plus 4x minus 5 minus 3. And like I said, you could also write this as cosine inverse of 3 over x plus 2, and then plus c.